So you guys should be on your 6-8 notes. We're going to be learning about absolute value graphs today. This is our last section in chapter 6 before we move on. And with absolute value graphs, what I'm going to do is teach you guys about something that's called a parent function, which is just like the beginning or the base function that you start with. And then I'm going to teach you how to use that base function to graph really, really easily. So the parent function would simply be y equals the absolute value of x. So go ahead and write y equals the absolute value of x. And this is what we call the parent function. That's basically what we're starting with. And then we're going to slowly manipulate or change the parent function to make our graph slightly different. You can just draw for your graph, because you are going to have to make some grid paper. You only have to go up to 2 in each direction. I'm going to do 3 just because I have room to do 3. Yes, go ahead. Actually, you don't have to, but you are thinking about inequalities. In inequalities, you would, yes. With our parent function, an absolute value function is going to create what I call a V shape. So it's going to be a V-shaped graph. Now, with my parent function here, if I weren't sure how to graph this, I could start with what we call an XY table. And I could pick some numbers to plug in place of X to result in my Y value. So I always like to start with 0. And I'm going to put that right in the middle. So I've got 0. And if I substitute 0 in place of X, what's the absolute value of 0? Just 0. So my first point is going to be graphed at the point 0, 0. Now, if I were to plug in 1, what's the absolute value of 1? 1. So I would graph the point 1, 1. If I were to plug in 2, what's the absolute value of 2? 2. So I'd graph the point 2, 2. And that is the right half of my graph so far. But I also want to know what my graph looks like if I were to go into the negatives. So I'm going to use -1 and -2. What's the absolute value of -1? 1. So at -1, I'm going to go up to 1. What's the absolute value of -2? 2. So I'm going to go up to 2. And we've got our other half of our graph. Yep.
Now you can also get negative y, right?
No, you can't because of the absolute value symbols.
Well, like, you're never going to have a graph where it's going to be...
You can have one pointed downward, yes. It could happen. If you had a negative in front of it, then it could open downward. Now, when you go to graph this, you don't have to make an XY table every single time. Your parent function is always going to start at 0, 0, and you're going to go up 1, over 1, up 1, over 1. Your slope is just 1. And then if we want to go to the left, you're going to go up 1, left 1, up 1, left 1. So that's what we call a parent function. We are going to use our parent function to graph some translations. And a translation is simply a slide. If you are translating something, you're just sliding it up or down or left or right. What? Or if you flip it, it would be a reflection. Today, we're just going to be translating it, so we're only going to be sliding it up or down, left or right.
So how do you translate it? You just add a number?
Well, we're going to talk about that on this page here. So now go to example 1. And example 1 says, describe how the graphs of y equals x. So this graph over here on the left is y is equal to the absolute value of x. That's the parent function that we just graphed. And y is equal to the absolute value of x plus 1 are the same and how they are different. So who can raise their hand and tell me something that's either the same or different about them? Either the same or different about these two graphs. Say that again. Ah, okay, thank you. Good. So they have the same slope, right? If you go up 1 over 1, up 1 over 1, up 1 over 1, or you're saying go all the way up 4 and then over 4, or go up 4 and over 4. So they have the same slope. So you could write they have the same slope. Yes, go ahead. They have a different vertex, very good, or they've got a different y-intercept, you could say. So they've got a different vertex or y-intercept. And what do you notice about the graph over here on the right that says +1? You just shifted up 1 unit. Yep. So this +1 right here just simply tells you, hey, instead of starting at 0, start at 1 on your y-axis. Any questions on that so far? Yes, go ahead. Exactly. If it were -1, it would. So if we jump to our next page here, we have another graph. And the question says, how is the following graph different than the parent function? So I'm going to go ahead and draw my parent function. You start at 0. You go up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1. And that's my parent function. And that's going to be your parent function every single time. You start at 0, up 1 over 1, up 1 over 1. And the question says, how is the following graph different than the parent function? Who can raise their hand and tell me what's different about my graph from its parent function? Very good. All right, we would add 3 instead of 0. We would say that it's raised up 3. And so since it's raised up 3, it would be y equals the absolute value of x increased by 3. That +3 would go outside of the absolute value. And that would just symbolize that that parent function is getting moved up 3 units. All right, example 2. You can just draw grid paper in here. If you want to grab some graph paper, you're welcome to. But for this one, it's actually pretty easy to do my graph paper. Do you see how it's got that -3 attached to it? So where am I going to be translating my graph? Down 3, right? So I just need to make sure that I'm going in the negatives to at least 3. I don't really have a lot going on in the positives necessarily. So we have to graph y equals x minus 3 by translating y equals the absolute value of x. So I'm going to start with my parent function. I'm going to start at 0, 0, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So that's my parent function there. And it wants me to translate that graph down 3 units. So I'm going to go on my y-axis here, and I'm going to go down 1, 2, 3. So I'm going to start at -3. But my slope is going to be the exact same. I'm still going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So that blue graph right there is y equals the absolute value of x minus 3, because we're taking that parent function and shifting it down 3 units. Any questions on having to graph those ones? All right, let's jump to our next page here. And go ahead and draw your graph for number 5. And while you guys are drawing that graph, I'm going to. Now, you don't have to draw the parent function for this one if you don't want to. If you think you can do this without graphing the parent function first, go for it. starting at 0 for this one. Where are we starting at? -4. Yeah. So we're starting at -4. And then what's your slope going to be? Up 1/1, yeah. So that would be my graph right there. Now on the next page, the directions simply say to write an equation for each translation of y equals the absolute value of x. So this time, we don't actually have to graph it. We just have to write what the equation would look like. Well, we're always going to start with our parent function, y equals the absolute value of x. And if I'm going down 9 units, what do I need to do? Take away 9. Good. For letter B, I'm going to start with my parent function, y equals the absolute value of x. And if I want to go up 13, what do I do? Add 13. Yep, add 13 to it. So for those ones where it just says write the equation, you do not need to graph, just simply write that equation. So go ahead and do number 11 for me. And what are you guys writing for this one? Very good. Yep, y equals the absolute value of x minus 6. Very good. I'm going to start up a